from this point on, we're going to jump into the nitty-gritty details of CI/CD and integrations and branches and management of all of this from a data perspective. And that's something which I really want to stress on throughout this entire webinar. That when we're discussing Git or when we're discussing these other options and DevOps in general, DevOps was primarily built for a development cycle of software. We, on the other hand, as data engineers, are dealing with a lot more. And when I mean lot more, I do mean a lot more in terms of sheer volume. That is the data that we work with. So let's put ourselves into the shoes and look at two scenarios where we try to apply CI/CD, how things work in a typical fashion, and how things work when you have a tool like Datagaps, helping you with the merging of branches, using test cases as code and more and whatnot. So we'll start with this particular deck. This is a basic 2-3 slider deck, and then we will showcase the same in the product ways as well. So let's get started. Of course, the very first aspect of the product is, well, you're going to have different branches within your existing system. Now, typically a 4-branch system is what people might recommend, but as you might notice, different teams and different projects are going to follow different set of rule sets based on what they're working with. So here I've added an additional UAT branch just for the sake of illustration. Because, well, if you are working with different projects, the code base that you choose or the way you want to integrate CI/CD into your system should work in that particular fashion. Now let's put up a business problem statement for us. Well, we have this set of branches, and what happens, say, once every month or once every 2 months, depending on your project, or once every 2 weeks as well if you're particularly unlucky, is that there are new transformation changes coming in. New requirements come in either in form of regulation changes, either in form of business rule changes, or it's just that you're updating your algorithms, and so the transformations also need to be updated. So new requirements arrive, and typical structure defines that the developer is going to fork from the main branch, create go into a specific feature branch, and then he or she is going to create all the updates, necessary transformations needed over there. Now, once he or she does all the necessary transformations, they are going to do some manual testing on top of it. Note, right here itself, there's a big caveat missing. The sheer fact that you're working on a feature branch implies that you might not really have access to the best quality of data that you would like to work with. Of course, access to production data inherently might not be possible as you're working in a development environment, but good quality data might still be missing right there. Moreover, the developer themselves in most cases are creating these test cases. They're trying to validate the system based on the output of their transformation data set, and they're trying to validate it based on just these use cases. And so they are trying to understand, well, are there any changes? Is it having any unintended effects? But in most cases, a developer is just going to ensure that the requirements are being worked on correctly and the transformations reflect that. They're not going to look back and see if there were any existing test cases, and if there were, those definitely will be reported. But all of this is happening manually, and that's a key factor here. We are in a CI/CD pipeline, but there's a lot of manual labor involved here, basically. Of course, that's just one part of the story. That's definitely going through a pull request, and once there's some feedback loops associated with it, when it's a particular, there's some understanding that, okay, this is incorrect, maybe this is something has to be fixed, so on and so forth. After this feedback loop, there's going to be a merge with the QA branch. Note, before this merge itself, there's going to be a pull request review. And while it's being reviewed, the developer, or in this case, the PR manager, has to go in and check, well, does the code look good? Well, everything looks good based on the basic test cases and the basic code that I see. So that's why we are going to merge it with the QA branch. And at this point on, there needs to be another round of testing. Now, the main reason here is quite straightforward. You would like to ensure that these new changes do not have any kind of associative changes with the other pipelines or other test cases, or more likely, the subsequent data flows and pipelines that you might have. So this is why another set of testing is mandatory in most definitions of ETL pipelines, because just because you add a new transformation does not necessarily mean that the validation done at feature level follows through to the validation at QA level. So here you have another round of tests, and mind you, these are going to be slightly different from the feature branch, because obviously you're going to have a lot more branch-wide testing done. And so there's another round of testing that you have to do. And in this case, you have to ensure that your changes have not inherently caused any unintended consequences or changes to the rest of your pipeline. And once that is done, the cycle kind of repeats itself for the one last time, depending on your use case, for the release branch. Now, of course, if you're working with a release branch, the intended way is to have a fork and then merge it and then run, and once again, another set of validations. And these validations run as a sort of final go through. These are the sort of validations that you might have worked upon when creating the initial deployment pipeline, which you defined as a validation pipeline for your ETL system. So this is something that's necessary, because as this is a final round of checks before this thing is being pushed into production. And so once again, another round of manual testing, another round of PR review managers going through the code, going through ensuring that, yes, everything looks good. And they are doing this based on the output of the transformation itself. The data looks more or less good, but hey, if you're working with trillions of records and billions of records, many people can just guess. You can't really go into the exact data set and look at it from a manual perspective. So yeah, there's a lot of manual aspects here, and this is not even considering the UAT branch that most people actually go for. Of course, when we talk about a UAT branch, it's most likely going to be a fork of the release or QA branch, depending on what you're going to work with. And once again, here you're going to have to do a lot of validation. And the worst part here is that in most cases, the QA testers and the people who are working between the feature, the development, and the UAT might not be able to share the test cases they might be working with. And so because they will have to recreate a lot of test cases, because again, they're coming from the QA, from the feature branch, as well as the release branch, there's a lot of excessive test cases and excessive work being done right here. So a lot of work being done on top of it. And now this is, again, once again, a lot of manual labor on top. And so this is something that we'll have to definitely work on, because again, there's a lot of manual aspect in this automated pipeline. And so we'll have to definitely work into it. Now, my next animation, you just saw that, yes, we have the deployment as well. That's the CD aspect of it. And if you're working with the code base, and if you have some deployment options ready, you can easily deploy the code base that you've just updated to the specific dev, QA, and UAT environments correspondingly. Note that in most cases, you're not going to be deploying the test cases, you're only deploying the code. So at this point, you're also losing the test cases that you spend a good amount of time creating. So this is a typical my pipeline. This is a typical CI/CD, and the air quotes are there for a reason as well. When you're working with data, there's a lot of manual processing here. We need to reduce the manual processing, and we need to make it easier for not just a developer, but for the one who is managing these PRs, who is reviewing them, to understand the exact impact of the corresponding changes that we do in an ETL pipeline. So with that, now let's jump into what exactly we recommend from this perspective. Of course, the problem statement will be very similar to what we are working with, but here let's take up 3 important pointers that any true CI/CD webinar cannot be without. The first one is that we need to ensure that we treat our test cases as code, especially when we talk about branches, when we talk about merging them, when we talk about deploying them, and with CI/CD. Test cases need to be treated as code, and this is true even in our data ETL pipelines. The second aspect is we need to automate the process as much as possible. The sheer fact is that the more we automate a CI/CD pipeline, the smoother the DevOps process is. Because if there's a change coming in, the change can be approved in an automated fashion, the reports can be generated in an automated fashion, and the changes go in much more quickly. And so you're ready for the next change that's coming in, and you don't really have to have really long periods of time where your release and your development, QA, and all of the branches are in a sync state. Finally, left shift philosophy is something that Dave has also mentioned in his deck. And what this basically goes into is fail faster. So if there's a problem that's going to come up within your system, you should capture it as soon as possible, because you wouldn't want to capture that issue once it's in production, or once it's towards the end at the final merge, and there you catch something, and now you have to redo the entire system and redo all of the test cases. And one other aspect that the key and I must have noticed is that we have quietly added one key aspect here, which is BI. Now, a lot of ETL pipelines leave BI out of the picture, but to be very honest, BI is one of the critical aspects of any ETL pipeline. The reason we are making all of these data sets, all architectures and databases, is to ensure that we can use them in a proper business intelligence platform. This could be Power BI, this could be Tableau, Cognos, any other tool that you might be working with. The main gist here is the transformational changes usually have an effect on the BI reports as well. And so validating a corresponding change without validating its impact on your BI platform is still incomplete. And hence, we have added ETL, ALT, and BI code base, because the ETL pipeline is incomplete without the BI code base, even if it's managed by a different team. So now let's jump into the exact same use case and illustrate how our application, or how any application with such functionalities, can really help boost the automation factor and really achieve true CI/CD in an ETL space. So once again, we have the same amount of branches. Requirements are going to come in, there's going to be a fork, and then there's going to be development on a feature branch. Once this feature branch has been developed, now here we see the primary difference coming into picture. You see the application, when you use an application like the DataOps suite, you have a test suite ready right from the get-go. Now, the various ways this can be interpreted is that a QA tester can receive the requirements at the same time as the developer and create the test cases in parallel. So the developer might not have to work on them or the QA tester might not have to wait for the developer to work on them as well. Alternatively, this also gets into account that, well, using Gen AI products and all of our other systems that are upcoming, these automated testing systems are going to be generated using our algorithms itself. Based on the changes that you define, the test cases can be generated. Of course, that's coming in our upcoming releases, and it will take a good amount of time before it's to the accuracy of a well-trained QA tester. But till then, it's a great help for the end user and the QA tester as well. The main gist here is that as soon as a developer has wrapped up his or her changes, the test cases run, and these test cases can be run on any specific branch. And these test cases are transferable. But most importantly, this test case is going to generate a proper report. The report is going to look a little like this. So this is a screenshot from the product itself, and this kind of tells the entire story in a nutshell. Because when you're a manager or anyone who's reviewing a particular PR, you need to have a good amount of information present. Mainly, you need to understand the difference, the impact that this particular change is going to have. Firstly, of course, on the dataset itself, and later on, as I will illustrate, on the subsequent datasets as well. So here we just illustrate that how a particular change, in this case, geography key on DIM customer from AdventureWorks, if you're aware of that, is what our dataset's going to be, their example datasets. And here we just define here, developer has done the following changes, and this is the impact on it, not just on this dataset, but the dataset between landing and curated as well. We get a good understanding of what the exact differences this impact has. We get to see from a profile perspective if there's a volume difference, if there's a profile difference, and you also get a good look at the actual data. And this is the critical factor. Since we are working with ETL pipelines, working on data is very important and it's paramount. And so the PR review or request report is going to generate everything for you, not just for that specific test case, but for the subsequent ones as well. I will illustrate this once we open this report in the product as well. That's the first part though. There's of course the feedback loop present, but once again, everything is automated. The test cases are present right there, and the test cases are very easy to deploy with anyone, even without any tech-savvy knowledge. So the feedback loop happens, and once the reports are approved and everything is approved by the end user, in this case, the PR manager, we move on to merging them to the QA branch. Once again, the validations are going to happen, but wait, this is much more easier because the QA branch already has its pre-existing set of test cases. Here, if you would like to attach the test case, it's just as simple as importing and exporting them. The application has inherent Git functionality, so you can basically treat the feature branch code. The code changes can be treated the same way you treat your code changes, merging the feature branch into the QA branch. The test cases will also be merged into the QA branch. That is, if you would like to. Of course, if you're going for a hotfix type of system, the application can handle that as well. In most cases, you will just create a new hotfix branch and go with it. But here, the test cases can also be merged to the QA branch of the test cases. And so testing is automated once again here as well. Now you'll be working with the QA data sets, but your test cases are already present there. And you can just be assured you're doing a full data validation on your existing test cases, and you're not spending any extra time on all of this. Once again, the reports are generated on the same front. Now, before our final aspect of the release branch, I did say that the consequences of this corresponding transformation can be done on other data sets as well. So the subsequent data sets, subsequent transformations, and most importantly, the BI reports. So here, what we mean by that is, well, say this particular DIM customer and geography key change is happening in your landing zone. If you're working with a medallion architecture, assume it's happening in the silver or bronze layer. Well, to see the effect of this corresponding system in your report, it's going to take a good amount of time, but you need to perform them because once you have these records in your golden layer, they're assumed to be perfect. And these golden layer records are going to be then used in your BI report. Assume it's Power BI or Tableau. So at this point, when you're running the validations, once again, be it on QA or in release, depending on if you have BI associations on that particular branch as well, you're going to run another validation. This one is going to include BI validation as well. And the reports is going to look a little like this. So let's spend a bit more time here and illustrate what we're doing here. This is a regression-based report. Regression here is comparing the impact of the corresponding system, not just in terms of data, but also in terms of the report and BI tool in this question. Here we see that our corresponding change has actually, in fact, caused some problems because the geography key, the way it was updated, was incorrect specifically for Europe. And so here we see that there's a change between the Europe datasets, the graphs that we see between 3.1 to 3.3. Of course, this is not just with regards to data. Something which I would like to illustrate in terms of the actual demo is also with regards to the UI elements of pure BI validation as well. So far, we are going with the assumption that, hey, this is all an ETL pipeline. But even if you're a BI manager, and if you're working from the perspective that I manage a complete BI tool, and I need to ensure that my BI reports are not being altered, that is something that we have seen time and time again with a lot of our clients. They have a very similar setup. Let's just go back to our branch. They have a very similar setup, except instead of working on an ETL system, this is their BI system altogether. They change reports, they update reports, they have a lot of transformational changes coming in. And since our applications, they can directly connect to the DAX queries, to the models of the BI tools that you're working with, they can apply a similar type of validation on the models as well as the reports. Regression is just one way. You can compare the reports against the data sets. You can compare reports against other reports. You can apply rules on top of your reports. Something as minute as ensuring a visual does not change its position, or something along the lines of ensuring that the title that you're working with, those fonts remain consistent throughout all of your reports, or that the alignment of the title should not be moved from center to left. Something as simple as that can also be applied within the application. And all of this comes with the aspect that all the test cases that we are discussing are transferable, not just between branches, but between each other test cases as well. One of the famous case studies that we have is of one of our clients using our application to deploy it in one specific environment or branch. And then so they deploy everything in one specific environment or branch. They define it there, and then they deploy it in 6 different branches and 6 different environments that they're working with. So in this basically they save a lot of amount of resources and time because of this, and that's one of the better success stories that we have within our application. Of course, to finish up this particular system, we understand that, well, if you're working with a UAT system, well, you do want to validate it, but here the validation once again is taken care of by the sheer fact that all the test cases that we were working with, you can easily bring them into the UAT branch. You can combine them with the UAT datasets that you're working with, and of course, configure them accordingly. Everything is going to generate its own specific report, but we are really reducing the amount of time it takes to actually get to this point. Because if you're working with a QA tester and you're a developer, and if you're going through all of this, instead of doing it one after the other, or instead of making sure that the other system is ready and trying to transfer your test cases between branches, you can do it inherently with our product. And that's the key aspect here, that all of this is an inherent part of the product system. So just to finish up the system now, just to finish up the example, now we're basically wrapped up most of our validations. Everything has been given a proper report, and all the test cases have been moved to the specific branches. But with regards to CD, not just the code, but those test cases are also going to be saved with the corresponding release. Now, for an easy example here would be, say, 3 months down the line, if you want to ensure that, hey, something happened to the change that we did 3 months ago. So while you can easily go back and see using versioning what exactly happened to that code, you can also see what exactly happened with the test case, which was meant to validate that specific code. So you're going to that level of validation and that level of, say, in this case, housekeeping, basically, of your test case management as well. In most cases, as you might imagine, test cases and validation of data is something of a priority at the very start of your entire project. But as the project moves along, once there are 30, 40 requirements that you have resolved, these things become quite considerably difficult to manage, as we have seen, and I can say from my personal experience as well. And so having a tool which can integrate with your existing code bases and can easily integrate with your existing branch system is, well, quite refreshing, fresh air on this particular front. And the one thing that I want to from this point on start is the differentiation between a typical use case on this and why the suite is much more powerful on this particular front. So I'll quickly move to the other aspect and just illustrate this particular screenshot. Again, I will definitely showcase this in the product as well, but it basically illustrates how our application does have complete kit functionality. But with that, let's jump to the actual product itself at this point and illustrate the different means. So this is the entire product. Of course, our focus today is not on the specifics of the product, but how exactly we work on this. So I'll just give a brief overview of the different validation use cases that we are going with. First of all, you see that yes, along with the basic dummy webinar container, we do have the production, release, QA, feature branches present right there. I'll be sticking to the production branch. That's where I have most of my use cases. And my use cases are not as simple as just a difference there. My use cases could be something as complex as validation of report against data, as validating a non-SQL to SQL validation, some regression, metadata transformation, and ingestion validation as well. Before I jump into the exact use cases, I'll just illustrate what my pipeline looks like. My data quality pipeline looks a little like this, where at the very first, I validate all the ingested data in my landing zone or at the vendor level. Then in parallel, while I perform some specific transformational validations, I also do a bit of metadata validation. And once everything seems to be good, I can apply a conditional clause before I move into the BI sector, where I validate not just the UI, but the data and also do a bit of regression. So in this particular fashion, we see that the entire pipeline comes together and each of the individual test cases have their own association Git functionalities. So if I want to say modify this and pull a very specific version of my metadata validation to a specific branch, it's just as easy as working with my Git systems right there. So if I go back to my test case right there, I can of course go pull a specific branch, commit, or maybe just discard the specific changes that I've worked on so far. So from this point on, I would like to just go into a few specific test cases in the next few minutes and maybe wrap up with that. Of course, the few type of test cases, and again, the reason I'm trying to illustrate this is while in the market, you might find a few set of tools which, basically go to this on a surface level. You do want to ensure that the test cases that you can work with can handle complex logic and complex set of validations. Here we see we are trying to validate this transactional data set across a multitude of dimensions. We're applying a good amount of rules on top of them, which checks not just quantity, but validating the actual amount, validating the aggregate, validating the pattern that we work with. And of course, all of this is on top of typical basic checks of nulls, composite key duplicates, and whatnot. These are simplified examples just for the sake of illustration. In profiling, we're also keeping track of everything ranging from the actual volume of data to the distribution of data, the amount of duplicates we see, the lengths, the minimum maximum values, everything is being kept track of. If something is amiss, we capture that as an anomaly within the system. And in machine learning code-based anomaly detection, this is something that's tuned up to 11 on this, because we give the end user complete access to the zero-code, low-code system where you can define your own measures, you can define your own categorizations, and the application finds the exact issues within the data based on the plethora of prediction methods that you define. So just a bit of shadowing on what exactly the product is capable of. This is based on validation, but if you go back to our basic example, this also gets into account of transformational changes, where you can connect to any specific source, apply any type of validation, in this case, any type of processing that you'd like to replicate, and then either save the transformed records directly or save the output of your transformed data sets. Say you want to work with the mismatched and matched records, you can save them as files or as views based on your exact use cases. Here, this is our example in question where geography key has been updated in our target. And to do that, I pick up the source. I reapply the transformation in my SQL. Again, I can use Python, I can use Scala, I can use PySpark, some custom scripts as well. And here, the result is quite straightforward. All the differences are limited to my geography key. And once again, 18 versus 20 tells the entire story. That, well, while the logic has been applied correctly for everything else, the logic between 18 and 20 has been disputed. And I've got this very early within my system. To quickly end this part of the demo, I'll quickly get into regression just to illustrate how easy it is to set up. See, the application just has to define what exact reports you're working with, and it takes care of everything else. Just to make some actual proof on what I was saying, while we are looking at data properly and some string values here as well, as we see with the exact example that I was showcasing, the application is also capable of running pixel-to-pixel validations between your reports. So here in this example, we see, yes, something as minute as the alignment of the title between reports. If it's changed or altered, the application can find that. And of course, you can define rules on this as well. If you want to define a static rule for a position, you can do that. However, if you want to use another report as a reference, or maybe the same report itself as a reference, you can do that as well. This is just one caveat of VI validation. Of course, as I've discussed earlier, we have a lot of different dimensions alongside which we can actually do this. All of this comes with a great plethora of integrations, custom integrations that you can create yourself, and of course, the integrations of CI/CD in this case as well. Here, the example that I can quickly illustrate is DevOps, where the application has integration with the repository, the pipelines, the test plans, and upcoming integration with epics as well. So something as simple as where you get into a board and you have a specific request that's coming up. Say this is the request that I might not work with, which is updating the logic. It can have an associated change in your ADF. And within the repos, not just your code change, but as you see, the test cases are also present right there. These are the test cases that I was illustrating. So everything is being managed in our production branch. I can, of course, go to a different branch if I would like to, and then look at the changes correspondingly there as well. But if I want to, say, merge everything to my existing pipeline, the suite is just one task within the existing pipeline. So here, let's go to one pipeline here, and I'll just illustrate how easy it is to add our particular pipeline, because once again, it's as simple as finding data gaps within the tasks and attaching it within your system. In this way, irrespective of what triggers or other aspects that you've defined within your system, the application just runs within your existing pipelines. And the same is true for test plans as well. After a one-time mapping system, one-time mapping activity, where you define what the actual validation of your test case here is corresponding to our suite. As you see, we can define the validation use cases within this particular test plan as well. And this is just one example. We have integrations with other Git functionalities, with other tools that works in DevOps as well. Something as simple as Jenkins also has a great amount of functionality right there. But this is one of the main aspects that I wanted to really dig into. Finally, as I did promise that at the start, I do want to take a look at my reporting section. Here you will see that a key aspect that I wanted to re-emphasize on is that while you can definitely create a bit of validation between the before or after, so basically before or after the change between the data sets, something you also have to definitely look into is the effect that this particular change is going to have on your consecutive flows, or in this case, the flows that follow that corresponding transform data set. Here we see that, yes, transform data sets are going to have an effect on the metadata. It's going to have the effect on BI as well. And something at this point here, as you see, you can, of course, dig deeper and see what the exact effect was in this case. And here, once again, it's the same result, but I do want to illustrate how easy it is just for a PR reviewer to come into this and see the exact changes, the consequences of that changes, the impact that it has throughout your entire pipeline till BI, and then, well, choose to approve it if they have to.